So we can get started for the next session. The next session sort of falls very neatly on from the last one. And this is telling everybody about an event that happened earlier on in the year, a workshop towards a transformative understanding of the ocean biological pump. And we're going to start with Mike Saraki from NSF, who's going to give us a few words of sort of overview, and then I'm going to talk, and then we're going to go into 3 topic-oriented talks from different people. So, Mike.
Okay. Can people hear me okay? Is this mic on? Okay. Well, NSF about a year ago or earlier than that started thinking about how, as information, we started to learn information about exports and NASA's interest in that, and that planning exercise was underway. NSF and OC decided to start thinking about how we were going to interact with that field program as it was being developed. So one way to do that has been to initiate this workshop that we held in February at Ocean Science, and it's particularly focused on the biology of the biological pump. And we were interested in, NSF always wants to be pushing the edge of science and the envelope of where we're going, and new stuff that will transform a field and discipline. So we're looking for ideas, and we really push this group of participants in the workshop to think that way and think about the biological pump ID concept has been around for 20, 30, is it 40 years? But it's not a new idea. And we were not sure if there were important new areas in that field in which we would do a major investment. So we sponsored the workshop on the biology of the biological pump. The goal was to identify these research topics where investments could make a significant understanding. The workshop was relatively small. I think there were 32 participants, and so we had to limit its participation, and there were people who wanted to participate who couldn't. So the report of that workshop is now public, and it's open for comment. The ideas of that report will inspire the community on what the important new ideas are in the biological pump for funding, and NSF is always looking for those new ideas and cutting-edge ideas, and also for community input to that. So our ability to fund and put money into this program will depend on what we see back from the community in terms of the new ideas and the enthusiasm, just like NASA is interested in community reaction to exports. So it's very analogous to that. We have no plans for any new funding for something related to exports out of NSF. What that means is that most likely the money will come out of core programs, and those core programs could be physical oceanography, chemical oceanography, or biological oceanography. And so we are still in the process of talking within ourselves about how we're going to approach this. We're watching, and we're involved. I've been on the SDT ex officio member, so I've been watching what's happening with NASA exports. Paul has been by, and Dave Siegel has been by NSF to update us along the way. And our goal, or if we decide that we are going to invest in this, and I do say if, the investment would be based on science within those programs, so it would have to be science related to those programs. It would be areas that address poor understanding but potential importance. And of course, we'd be interested in new approaches, new methodologies, and new instrumentations, or new conceptual frameworks to apply. And also any synergies with the NASA exports program. So we'll be coordinating with NASA over the next few months about how to do this. It's all going to happen very quickly. We're not going to have a new solicitation. We're not going to say NSF is now funding a special program on biological pump. That's not going to happen. What does happen, we'll let you know as soon as we know. And I hate word slides, but I put my points, everything I just said is on this slide for those who learn better by reading. And also it'll be in the record for this meeting for people who weren't here if you want to refer back to sort of where we were at this point in time. So having said that, I think Adrian ran the workshop, and we had a great science advisory team steering committee running that, and many of them are here, and we'll be hearing some of the ideas that have been inspired by that workshop. So,
thanks, Mike. So, just to quickly go back here, this is the organizing committee for the program, for the workshop. So we tried to cover as many bases and new approaches and possible new ideas that we could in getting our invitees. So we've heard a great deal already about why now. And so one of the things I'd like to sort of say is, why should we sort of emphasize the biological pump now? We've heard a great deal this morning about exports program. That's definitely one thing that can provide a great deal of context to any future research in the biological pump. On the right-hand side, there's a picture from Lionel Guidi's 2016 paper. And I put that up there to really highlight the fact that there are a large number of new techniques, observational techniques, data analysis techniques. There's new data sets that are becoming available on things that we didn't necessarily think were important for the biological pump. And these are sort of opening up glimpses into things that we might have been missing. They may not be important, but they may very well be important, and we'll talk about some of those today. So we think that the time is ripe now for a really concerted effort to try and understand some of these newer phenomena and how they relate to our understanding of the biological pump. And the aim is to really try and develop an understanding that is predictive, so that we can actually know how things will change in the future. So this is a very, very rough schematic of sort of like a much more traditional, the kind of thing we might sort of teach our undergraduates about what the biological pump is. I know there's a huge amount of things that are missing from here, but it's sort of that overall schematic that you see, phytoplankton in the surface waters, individual cells settling, aggregates forming, zooplankton consuming those phytoplankton, fecal pellets and aggregates settling, getting remineralized by bacteria, causing an attenuation of flux as you go deeper and down with depth. So we wanted to try and sort of tease this apart and begin to look at things that are not necessarily in here, that may or may not be important. So we held this workshop. It was right before the Ocean Sciences meeting. There were 32 participants. NSF and NASA were there, program managers. So Mike, Bill Miller was there, Paula, Lisa Clow, Cynthia was there, a whole bunch of other people. And from that, we developed a white paper. And that white paper is now open to the community for comment. And just as with the exports program, and Paula emphasized this, and other people have emphasized this morning, this whole effort will only work and be worthwhile if the community responds in terms of comments. So you all have your little flyer in your folders, and on one side is exports, and on the other side is the biology of the biological pump. And if you look at the bottom, there is a URL. That URL will lead you directly to the white paper. Unlike the exports program, this is only about 25 pages long. So it's relatively easy to read. You could read it on the plane home after this meeting. The comment period officially ends on the 1st of August. So please, please read it and send your comments, positive, negative, or otherwise. So in order to sort of direct this effort, we had a series of focus questions. Just sort of very briefly talk about them. We were looking at particle formation in the upper ocean, mesopelagic attenuation, the characteristics of biogenic materials, processes, newly revealed biological pathways, things like viruses, how might viruses affect the biological pump, food web community structure and trophic interactions. So there's a strong overlap with what is being done within exports, but there's also a lot of new stuff. And what we wanted to do was to come up with a set of research priorities. So how do you reach consensus? This, to me, is a fantastic photograph. Irrespective of one's political leanings, it shows how not to achieve consensus. You know, you've got the alpha in the room who is dominating the discussion. You've got a couple of other people shouting them down, and you've got the shy guy at the end who's sticking his hand up very politely, hoping that the moderator will spot them. So one thing we didn't want to do is to have this kind of a meeting. We wanted to have a meeting. I think I've lost my mic. We wanted to have a meeting. We wanted to have a meeting in which everybody would contribute. So what we did was we decided to adopt what's called the KJ method. And the KJ method involves a large number of sticky notes. And so those people who were involved in the meeting will probably have a deep-seated fear of sticky notes now. So basically what happens is everybody writes their ideas on sticky notes. It's a big brainstorming session. There's minimal discussion, almost no discussion whatsoever. And then so that's this very first idea here. And then these get grouped into similar groupings. Again, no discussion. They then get named. Each one of these groups gets named. Again, very, very little to no discussion. And then they get ranked. And after this phase, then there is discussion about, well, you know, maybe this sticky goes over with this sticky, maybe these groups are the same group. And that way you can come up with a group of priorities. Now, what is amazing with this method is that we were able to get 4 separate groups thinking about the same question, coming up with broadly similar ideas and about what priorities should be. And I've heard from Rob today that actually this method works with 11-year-olds. So it has to work with scientists. So this is what we did, and we came up with 3 broad categories, within each which there were several subcategories of priorities. One was looking at food web regulation of export. Another one was looking at variability in space and time. And the other one was the dissolved particulate continuum. So this linear picture of how material moves from the surface ocean to the deep ocean in the biological pump is now being supplemented by things dealing with episodic events, blooms, jellyfish falls, salp blooms, these kind of things. Different pathways, zooplankton, viruses, parasites, how do these things affect things? What happens on climate change timescales? The dissolved particulate continuum, how does that work? So there's a lot of new ideas that are coming through. So again, I encourage you to read the report. It has this nice word thing on the front. Here is the URL. And again, comments are due by the 1st of August, so please read that. And so with that, we're going to move into 3 much more directed topics.